here. Oh, and this gives me a chance. If you are not here on a day and there is no YouTube video, that means either I wasn't here or we didn't do anything new. So you look in your book, and if the next page in your book is something that you already know how to do, that's the page we worked on the day you weren't here. Everybody understand? Okay. Sorry, Addison. Let's slide along now to 8, 4, 8, and 9. And there they are. 4, 7, 8, 9. And there they all are. Check your work. Make sure you did okay. And again, I remind you, if you want extra practice, please notice I did not assign this whole page. You can always do a little more of it. There's always a kid or two that are like, I'm not quite sure. Can I have some extra practice? Here it is. And this will happen all the way through your book. There's work in here that I will assign a bare minimum of. And then, but there's more there for you to do if you want extra practice, okay? Any questions about these 1, 2, 3, 4, 5? If I were to guess, I would expect questions in 8 and 9. Gersahil. 4. Sure. Okay, so I'm going to split this up. I'm going to use different colors. I find color to be useful here. So in 4i, I have e to the negative 4 over e to the negative 6, yes? And I'm only going to deal with that right now. There's two ways, again, you could look at it. You can do the rule. Are they the same base? Yes. So what I have to do is do e to the negative 4 minus negative 6, right? And what is negative negative? So that is e to the negative 4 plus 6, which is e squared. Is everybody cool? Easy peasy, right? We're just adding. Everyone's good, right? Now let me show you what I meant by knowing what's really happening. Is that allowed? No. So where should that go? To the bottom. Is that allowed? So where should that go? To the top. Now, how many e's are up top? 6. And how many are on the bottom? So I can get rid of those 4. And how many of those 4 can I get rid of? How many of those 6 can I get rid of? 4, because I just got rid of 4 down here, right? So if I get rid of 4 of them, I'm left with 2. E squared. Same answer. Right? And there's a third way you can look at it. In math, if you have the same thing on the top and the same thing on the bottom, you get to have 1, right? Everyone agree? No matter what I write there, I could write a $sign over $sign. That's still 1, isn't it? I could write fish over fish. That's still 1, right? So what if I wrote e to the negative 4 over e to the negative 4? Is this still e to the negative 6? I got 4 negatives and 2 there, right? Everyone agrees? So what do you see right there? They're the same thing. That's 1, isn't it? So they disappear, leaving me with e to the negative 2. Is negative 2 allowed? Not as an exponent, so it would just move up to the top. 3 different ways you can look at it. Who has to make the decision? Who is going to make the decision for how you are going to look at this question? You are. Whatever works for you. Everybody cool? If they're the same sign, it's easy to cancel. That's what I personally like to do. So, e to the negative 4, e to the negative 6. I'll change color. f to the 5, f to the negative 9, and g to the negative 8, g squared. Now, if I only gave you just the red one, you could all do it in your sleep, right? We've already done that one all three ways, yeah? So we'll look at the red one. I see they're both the same sign. Personally, I'm going to cancel those 4, which means I can cancel 4 of those, which leaves me with e to the negative 2 in the denominator, which isn't allowed, so I bring it up to a numerator. Everybody okay? Now let's look at the blue one. Are they the same sign? No, so I can't cancel them, can I? All right, so I got to use one of my other methods. So I could do the subtraction thing. This is 5. Oh, I should be doing this in blue. This is, of course, 5 minus 9. Right? Which is what? Yes, Garcelle?
Where did you get the G from?
G. Well, that's a G.
It's a G, it's just cursive on the page.
But even if it's an 8, you would still write, it would be 8, and the exponent would be the same, right? And you would just write 8 squared, or whatever it is.
I thought the same thing as
So we could do this. What would I do with the 2 negatives? It would be addition, and I'd have 14, right? The third way I could look at it is that allowed. So it would come up, yes? So now I got my 9 right there, so I got to have f to the 14th up top. And then g, different signs. So even if you said that was 8 to the negative 8 and 8 to the 2, where should that negative go? Down. So I have 8 to the 8th, same base, yes? So it would be 8 to the 10th, or g to the 10th. Everybody cool? All right. Everybody okay with 8 and 9? Nobody wants to ask about any of them? Which one? 9, which one? B, obviously, the only one we have. All right. So, if I gave you this, 3 times 2, oh, that's a bad one. 3 times 4 divided by 2. What's the answer? 6. Why? Why? Order of operations. They're equal, right? Division, multiplication. So you just go through it, yeah? Okay. So, what do I have there? I have 4 times 12 divided by 8. What's 4 times 12? I'm bad at my 12 times table. 48. What's 48 divided by 8? 6. So that part's easy. We're done. Then we just go to exponents. A to the negative 7 times a to the negative 5. What math do I do when it's multiplied? I add them, right? So what is negative 7 and then negative 5 more? Negative 12. Is that allowed? No. So it goes down there, right? If I was done, but am I done? No, because then I divided by 8a to the negative 4. So that is add or subtract when it's division. Subtract what's negative 12 minus negative 4. That's negative 12 plus 4, which is negative 8. Now, is a to the negative 8 allowed? It would be up here, but it needs to be down there. Everybody good? Once? Addison.
Isn't the 6 connected to the A of 6A?
Where? This 6?
Yeah.
Yeah, it would be 6a to the negative 8. But the a to the negative 8 isn't allowed because the 8 only applies to the a.
So then you can drop the 6 off and put it on top?
Yes. Because remember, exponents only apply to whatever is directly to the left of them. So a to the 8th is different than 6a to the 8th, which is different again than 6a to the 8th. In this one, there's 8 a's and 1 6. In this one, there's 8 6's and 8 a's. Everybody cool? Sweet! These are the toughies. Have a look. Make sure you're comfortable. Interesting. Does anybody want to talk about any of these? I probably need to, and I understand that. Okay. All right. Now, here is something I would like to talk about before I talk about this. You need to be honest with yourself. Where do you think your mistakes are happening here? Here's my guess. This looks very busy, right? There's a lot of stuff happening there, isn't there? But everything we've done this year has been add, subtract, multiply, or divide, right? And we learned that in the past, yeah? So let's take a second and let's think about this. How could we make it simpler? Would I know what to do if I had just... Oops, that was too big a whiteout. Hold up. If I had just numbers, could you do that? Okay. What would this part of it be? How do I do -4 with the 3 out there? What does that mean? Jacqueline? Right, -4 times -4 times -4, right? So that would be -64. Does everyone understand? Okay. And then the 5 has no exponent, so it's just going to be -5. Is everybody cool with that? Okay. 2 negatives multiply together get me a positive. 64 times 5, well, 60 times 5 is 300. 4 times 5 is 20. So I got 320. Is everyone cool? Right? Easy, yeah? All right, well now let's add what else is there. So now we know it's going to be 64 and -5, right? So I'll get out my whiteout. Now I've got p cubed. What's that? What does that mean? P to the power of 3. And I got another p to the power of 3, right? So I got P3 and another P3. So how many P's is that? P to the power of 6, which I got right there, right? Now, get out your whiteout again. And obviously you're not going to white out a question. This is mental whiteout, right? So now the only thing left is this Q all by itself, right? Q cubed, right there. Is everybody with me? Don't look at the whole problem, because the whole problem looks scary, doesn't it? Like, be honest, they look a little freaky. If I told you tomorrow we were going to walk to Newfoundland, that would be scary, wouldn't it? But if I told you tomorrow we were going to walk 5 kilometers, we could do that. If you ever put your step counter on your phone, a great many of you are walking 5 kilometers in a day just around the house. So you could do it in your sleep, right? It's a regular day. So in a week, if you walk 5 kilometers a day just around the house, you're going to walk 35 kilometers, right? So in 10 weeks, you're going to walk 350 kilometers, right? In 100 weeks, you're going to walk 35,000 kilometers. 100 weeks is only 2 years. Everybody picking up what I'm putting down? Do you think about how far you walk in a day? Should you think about how crazy this question looks? Or is it just one step, one step, one step, one step? Let's look at C, because Carmen wanted to look at everything. If I gave you this, 4 times 6 divided by -3, could you do it? What is it? -8, because 4 times 6 is 24 divided by 3, right? This is A times B divided by C, correct? Right? So how is this any different from this? Isn't this A times B divided by C? Okay. So what's different? We've added exponents to it. But we already know how to deal with exponents, don't we? What is 4 times 6? 24. What is m to the 4th and m to the 8th? M to the 12th. And what is n squared and n to the 4th? n6 over -3 m6 n6. Now, you already know this, like terms. Numbers work with numbers. That shouldn't have been read. Numbers work with numbers. And letters work with letters. So what's 24 divided by 3? -8. 12 m's up top, 6 m's on the bottom. You have to decide. The way I do it again, I see they're the same sign, so I just cancel. If there's 6 down there, they're all gone, and I'm losing 6 of that 12. So there's 6 left, m to the 6th. 6 and 6. Same thing on the top, same thing on the bottom. What is it always?
0.
Not 0, 1. And -8 m to the 6th times 1 is -8 m to the 6th. Everybody cool? It seems complicated. Why? Because it looks complicated. It's just like a jigsaw puzzle, right? When you dump out the jigsaw puzzle, it looks complicated. But when you're done it, it's one picture, right? Even though it's actually 1,000 little pictures.
Why'd you get rid of the n though?
Because I had n to the 6th over n to the 6th, which is n over n. N divided by n is 1, 1, 1, 1, 1, 1. What's 1 times 1 times 1 times 1 times 1? 1. And this is saying everything is multiplied by 1. So, what is -8 m to the 6th times 1? -8 m to the 6th. Okay? Yes. 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 Bueno. Hasta luego.
I don't know what that means.
Oh, okay. Hasta próxima? No? All right. Easy, right? Take the steps that you know. Break it down. Right? When you're building a house, do you worry about the roof before you've got walls? No, so you build the walls. Same thing here. So let's look at F. I'm going to say to myself, self, I see that 2 right there, and that applies to this whole thing, right? So I'm going to take my mental white out, and I'm going to deal with just that. Does that 2 apply to everything? Yes or no? Sure it does. What is 5 squared? He waited patiently for his grade 10s to tell him what 5 times 5 was. 25. What is x squared squared? X to the 4th, cuz. And what is y squared? Y squared, yes? Now I look at the second part of it. I get out my mental whiteout, and I have a look at that. 3 cubed. Well, Mr. Myers, I can't do that in my head. So what do you do? What do you get to do in math class when you can't do something in your head? You get out your calculator. 3 cubed. 3, exponent button, 3. 27. X squared cubed. What's that? X squared cubed. So I've got x squared, but I've got it 3 times. How many x's is that? 6. And I've got y to the 4th 3 times. 4, 8, 12, right? Now, numbers with numbers, letters with letters. 25 times 27. Mr. Myers, I can't do that in my head, so where do you go? Calculator, and it's 675. X to the 4th and x to the 6th. What's that? I got 4 x's, then I got 6 x's. How many x's is that? He waited patiently for his class to tell him what 4 and 6 was. 10. And then I had how many y's? 14. Yeah? Yeah. Isn't 12a exactly the same as 11c? Multiply, divide. Now, B and D are a little bit different. What makes B and D different? And I'm going to make this bigger because I'm seeing a few people squinting. What makes B and D different? Is it still something times something divided by something? The bottom is in brackets. It's got an exponent, and so does the top, doesn't it? So it's just one more new step to add, right? So you all know the order of operations. What's the first thing you're supposed to get rid of? Well, brackets is what everyone says because they mean brackets like this, x plus 3, right? Or, wait, let's take the x out of there. 3 plus 3 divided by 2. They mean that kind of brackets that have a plus or a minus in them. Do we have any of those brackets here? No, because this is all one thing, isn't it? That's all one base, right? So that's not a bracket. So what's next on the list? Exponents. Is there an exponent that has a base? So that's what I got to deal with first. So again, go step by step. I'm going to color these 3 things. Where is there something I should do right now? Green, blue, or yellow? Yeah, go. So if I'm going to deal with the blue one because it's got an exponent, am I going to do anything to the yellow and the green? Yet. No. Should I write them down? No, it's not up to you, Jazri. You need to write these down because you guys have trouble putting more than 2 steps together in your head. A lot of you do. Not all of you, but a lot of you do. If you write it down, it's very difficult to do wrong. So there's my yellow one. There's my green one, because I'm not touching them. But I am touching the blue one. -4 squared. What is that? I got time. +16. P squared. What's that? P squared. Q to the 3rd squared. What's that? Q6. Now, does that look exactly like 2 times 3 divided by 2? Does to me. So, what do I do with -3 and 16? Multiply. What is -3 times 16? I can't do that in my head, Mr. Myers. So what do? Get your calculator. It's -48. Now that's taken care of. What should I do with P and P? Add them. If you know what's happening, you know. This is PP. Ha 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 ha. Should have written it in yellow. PP. It's not poopy, it's PP. It was poopy, I would have written it in brown. Now how many P's are there? 4. And Q5 and Q6. So how many Q's are there? 11 over 8P4Q4. Numbers with numbers, letters with letters. 48 divided by 8? -6. 4 P's up top, 4 P's on the bottom. What happens? It becomes 1. Do we ever write 1 when we're multiplying? Nope, so it's gone. 11 Q's up there, 4 Q's down there. What happens? I get rid of those 4, and how many of those 4 can I get rid of? I did it again. How many of those 11 can I get rid of? 4. Leaving me with Q to the 7th. Now, a bunch of you are going to do something with that -6. Should you? Why not? Is it a base or an exponent? It's a base. Are negative bases allowed? Yes. Of course they are. And let's look at the last one, which is far and away the hardest one. Which makes sense because it's the last one. Again, yellow, blue, green. There's one thing there you're not going to touch yet. Which one aren't you going to touch yet? Yellow, because it doesn't have an exponent outside, right? So yellow is going to stay the same, so I'm going to write them out because then I can't do it wrong. What's going to happen to blue? Where does that 3 go? What does that 3 mean? It applies to all of them. So that 2 is going to be cubed, that x is going to be cubed, and these 2 y's are going to be cubed. So how many y's are there going to be? 6. What is 2 cubed? 8. X cubed, y 6. Over, what do I got to do with the green one? What does that 2 do? Goes everywhere. Does that 10 get the 2? Okay, so 10 squared. What's that? 100. X3 squared. So how many x's are down there? There were 3, but there's 2 groups of 3, so how many is there? 6. And how many y's? There were 8. There's two groups, 16. Now, doesn't this look exactly like what we've just done 4 times? What's 5 times 8? Negative 40. X to the 4th, x to the 3rd is x to the 7. Y to the 5th, y to the 6th, y to the 11th. Over 100, x6, y16. Numbers with numbers. Would you ever have left 40 over 100 if you were in Mrs. Bad Crumble's grade 4 math class? Would you ever have left that fraction as an answer? No, why not? You would, Mrs. Bad Crumble called it reducing. We call it simplifying, right? So what is that? 2 over 5, right? Right. So I've got negative 2 over 5. That covers my numbers. What do I do with the 7 and the 6? Are they the same sign? So they're pretty easy to work with, right? Can I get rid of these 6? How many of those 7 can I get rid of? 6 of them. So what's going to be left? Just 1x. 11, 16. Can I get rid of these 11? They're the same sign, so nobody has to move. Can I get rid of these 11? Yep. How many of these 16 can I get rid of? 11 of them, leaving me with 5. And that y to the 5 is down there, so it stays there. Is everybody cool? All right. That makes me extraordinarily happy. Now, if I am not mistaken, yous guys were supposed to have a quiz. Yous guys were supposed to have a quiz. Oh no, your quiz is later on. You're right. So we are now, if I am not mistaken, and I don't think I am, we have finished all the exponent stuff, and we are moving on to page 19, please. The projector is tilted. I've been asking them to get it straightened for a long time. They haven't come in to do it. So if you want something done, you should do it yourself. But that would require getting a ladder and then screwing stuff in. That's a pain in my butt. Huh?
Your desk is pulled up.
I appreciate, Braden, that you think I am tall enough to reach that from here. You have not seen me stand up yet. I am a short man. I am 5 foot 8 inches tall. Why? So you can see that I am 5 feet 8 inches tall. You have a measuring tape handy? There. See? Barely taller than when I was sitting. What's really funny, Jade, is when I sit down beside regular height people, like Mr. DeVries, who's like 6'3", when we sit, we're almost the same height. Because I have a normal length body, but I have little tiny drumstick chicken legs. It's very difficult for me to buy pants. Because I have short little legs. I don't know if any of you have that same problem as I do, but it is difficult. When I try to rent a tuxedo and they try to measure my leg, I say, it's 28 inches. And they are like, no, it is not. You're a grown man. You have a longer leg than 28 inches. And then they measure my leg, and they say, your leg is 28 inches. And I say, I know. And they say, that's crazy. And I say, I know. It's hard to buy pants. True story. My wife is the complete opposite. She has a very tiny little body and normal length legs. So when she sits down, she looks short. But when she stands up, she's normal. Now, my poor daughter has gotten a little tiny body and little tiny legs. So she's really screwed. She's like this tall. No, she's not, but she is short. She looks much younger than she actually is because she's so tiny. Most of you have seen my daughter because, as you well know, she was the little white girl in Love Punjab. The movie Love Punjab. You probably haven't seen it. No. But my daughter is the little tiny white girl in it. How many of you have seen that movie? Only 1, 2, 3, 4? My daughter's the little white girl in it. My son was on the 100 again. But he just got a new acting job on a new show. It's called Firefly Lane. It's new. I think it's based on a book. He plays a mean bully kid who hangs out the bus and yells at some girl. All right, let's do math. Page blah, 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 blah. 19. So, the real number system. These are the numbers we use for regular math. Now, in physics, sometimes we use numbers that are not real. We use things called imaginary numbers. You think math is difficult with the numbers that are real? Wait until you go far enough up to use the numbers that are imaginary. Like the square root of -4. No. You all do not have to worry. There is very little chance that you will actually deal with imaginary numbers. But I feel I need to tell you that they exist. Okay? Okay. So let us start. The real number system is broken down into 5 categories. The first category are the natural numbers. That should have been a highlighter. I keep tapping it and it doesn't make the highlighter. Natural numbers are what I like to call the counting numbers. If I said to you people, let's count, class. When I clap my hands the 3rd time, let's all count together. Everybody ready? 1, 2, and those of you that are going to get out of grade 10 started counting at 1. Those of you that didn't, we'll see you next year. We would always start with the number 1. Now, is number 1 the first number? Of course not. So 1 is what we would start with. 2, 3. How long could we count? Muskan. Till infinity. We would never stop because infinity does not exist. Because when you get to infinity, you would just add 1 and you'd be past infinity. Infinity doesn't exist. So, there we go. Everybody cool? Everybody understand? So the natural what? You could never stop counting. We just don't have names for the numbers. Okay? The biggest number I know is a nonillion, which is a 1 followed by 9, 12 is 4, 15 is 5, 18 is 6, 21 is 7, 24 is 8. 1 followed by 27 zeros is a nonillion. No, that's 1 followed by 100 zeros.
So isn't that the biggest number you have?
No, because it is, you're right. All right. Good call. Everybody cool? So the natural numbers are infinite. Does everybody understand? Now this is where it gets weird. This is why math is so both frustrating and cool. This is an infinite amount of numbers, yes? Well, the whole numbers are the natural numbers plus 0. So it is 0, 1, 2, 3, up to infinity. Now this is where it gets strange. Which of these is a bigger group of numbers?
Whole numbers.
Aren't they both an infinite amount of numbers?
Whole number has a 0.
I'm aware of that, but aren't they both an infinite amount of numbers?
Yeah.
So aren't they exactly the same? They're not the same, are they?
No.
But how many are in each set? Infinite. Everybody see? It's weird, right? So, you're intelligent young people. If the natural numbers are the smallest group, and then the whole numbers are the next biggest group, even though they're both infinite, integers, are these going to be bigger or smaller than whole numbers? What do you think the integers are? Negative infinity, ... negative 2, negative 1, 0, 1, 2, 3, ... up to positive infinity. So the integers are the wholes plus negatives. Now, when I use the word bigger and smaller, that has more than one meaning in math class, doesn't it? Right? 7 is bigger than 4, yes?
Yeah.
But as a set, which one is bigger? They're the same, aren't they? They both have one number in them, yes? So, the integers, even though they've got all of these guys down here, is it still infinite? So isn't it the exact same amount? But it's not the exact same amount, is it? And what would happen if you added up all the integers? How much would you have? How much would you have? Say it out loud. 0. Why? Because at one point you would do negative infinity and positive infinity. So you actually would have nothing. Everybody cool? Yeah. That's why math is weird. Now, for our purposes, do we need to think about math like that? No. No, of course not. But I do want you to see that math is like that. Okay? Now, here is what is important. No fractions, which automatically means no what? If there's no fractions, what else can there not be? No decimals. The naturals, wholes, and integers, no fractions, no decimals. And why is that important in math class? Because sometimes you're counting things that you can't have a fraction of. Does everybody understand what I'm saying? If I was counting people in the room, could I have a fraction? No. Because even if, and I'll do the joke again, I can't remember if I did the joke with this class, even if I had a horrible accident where I had my left arm and my left leg cut off, none of you would have to worry because, of course, I'd be all right. But I would still be a whole person, wouldn't I? All right. So we're cool there, yes? Okay, so now put another line because this is where it starts to get weird. Rational numbers are what you guys call, or what is known to you as fractions. Okay? Rational numbers are fractions and they're related decimal. What? What do you mean by a related decimal? It's not like two fractions can, be brother and sister and then have a decimal that's their cousin. That's not what I mean. This is what I mean. Fractions we'll do first, and I'll highlight them in yellow. So I will talk about them in yellow. If you can't read this, tell me now. Is that readable? Okay. This is a fraction. I'm writing it in yellow because I highlighted it in yellow. There are some rules. Fractions, to be rational, must follow these rules. X and Y must be integers. And rule 2, Y can never equal 0. Everybody with me? All right. So now I want you not to write down what I'm about to write. I want you just to think. I'm going to come over here onto blank paper. I'm going to use a regular color. Is this a rational number? Yes or no? That's all I'm looking for. Is that a number over another number? And are they both integers? And is y not 0? So that's rational. Everybody agree? What about this? Yes or no? Yes. Number over number, and that's an integer because it's negative. Everybody cool? Everybody's good? Okay. Jade says yes. Anybody else is in the yes camp? Who's in the no camp? Why do you think it isn't? They're not integers anymore, are they? Okay. But, what if I multiply that by 100? Or, sorry, by 10. What do I get? 21 over 36. Is that a rational number? So if that's a rational number, is that a rational number? Yes. Everybody's cool, right? Okay, now the last one I want to do is show you this one. 2/3 over 1/2. Is that a rational number? You think so? Okay. Is there anybody that thinks, no, that can't possibly be a rational number? Who knows that I'm faking you all out? And something weird is going to happen here. Excellent. What math is happening right there? Divided by. So isn't this 2/3 divided by 1/2? And isn't that 2/3 times 2 over 1? Yep. And isn't 2 times 2 4 over 3? And isn't that a rational number? So is that a rational number? Yes. Everybody cool? Why am I showing you this? Because if you just learn the rule, you all told me, or a great many of you told me that and that was irrational because you only learned the rule. Everybody with me? That's why learning the rule only is often not enough. Everybody cool? Okay. So that covers our fractions, yes? But I also talk about related decimals. So, what is, and I'll do these in green, is 1/2 rational? Yes? Okay. How do I make 1/2 into its related decimal? Gursil.
Convert it into 0.5.
Yeah, how? What do I do to make that happen? What math do I do? Everybody knows half is 0.5. Okay, let's make it a little harder. 33 over 47. Is that rational? How do I make it into its related decimal? Yeah, you know.
I do.
Yeah, you do. Addison?
2.3 and 4.7.
Oh, I see what you're doing. Not quite. Jasreet? I do division. 33 divided by 47. Everybody's cool with that, right? Okay. So if I were to bust out my calculator, which I have right here, 33, I know it's wicked, hey? Divided by 47. Now, if that is rational, and we know it is, right? because they're both integers, then its related decimal is rational. That big ugly number is a rational number. Everybody cool? Now, there's a reason I chose weird numbers like that, because it did this. See that? Everybody sees it. You can see it on the screen. It's going to stay there. It's going to come back in a second. 1 over 2 is 1 divided by 2, and it equals 0.5. So I'm going to go back to my calculator. 1 divided by 2. There it is. Easy peasy, right? Okay, what about this? Is 1 divided by 3 a fraction? Is it rational? It's an integer over an integer, right? What's that? 1 divided by 3. Now, here's where I hear what you're saying, Jacqueline. That 3 is going to go on forever, doesn't it? But that is rational, isn't it? 1 over 3. So we have to have a rule for this. Since we know this guy is rational, his related decimal is also rational. So here's the rule. Rational numbers are decimals that end like 0.5 or repeat like 0.33. Now, sometimes you're going to get a decimal like 33 over 47 that fills up your whole screen, and it doesn't look like it's going to repeat, does it? Does it? But why does this 6 end here? Because your calculator screen ends. At some point further down the line, this will start to repeat. Because this is rational. Is everybody cool? All right. And then obviously what's left? Irrational numbers. These guys are simply this. Any root that fills up your screen for your purposes. Okay? So if I go to my calculator, I do the square root of 2. See how my screen fills up and it doesn't repeat? That's an irrational number, because it will never stop and it will never repeat. So irrational numbers are non-repeating decimals. And most of them are these, like the square root of 2, the square root of 3. What about the square root of 4? What's the square root of 4? 2. So it stopped, so it's rational. Everybody cool? Now, what's the most famous irrational number? Pi. Pi is up to trillions of decimal places with no repeating. It goes on forever. There's a bunch of other ones, but for our purposes, these guys that don't work and pi are the ones that we deal with. Everybody good?
Yes.
All right. Turn the page over.
How many digits of pi do you use?
Like 5, because it doesn't do any good to know them.
Memorize the 100.
I know a lot of people have done that. I've memorized the entire English language. As have most of you.
Every word.
Huh?
Every word.
Every word I would ever need. Does it make me any better? No. Would you think I was stupid if I didn't know my phone number?
Yeah.
What's your phone number? On your cell.
On my cell phone.
Yeah.
778-245-3307.
What's your mom's phone number?
778-875-3307.
What's your aunt's phone number?
I don't know my aunt.
Aye. Let's talk about just one A, B, C, and D, and then you guys are gonna be working. Make that a fraction. Who remembers how to do it? What's that first spot after a decimal? Tenths, right? What's that second spot after a decimal? Hundredths. I know, you got to do that, right? So this is 12 hundredths. Yeah? Would you ever leave that fraction? Why not? It's not simplified. And what is it, of course? It is 3/25. What is 0.437 as a fraction? Thousandths. Right? How do we remember how to do it? It's the decimal over 1 and then that many zeros. Ease, bees, lemon squeezy, right? What's B? There's a trick to it. What is it?
1/10.
What's that little line over the 1 mean? So this is 0.111111111 for how long? Forever. If it was 0.1, it's 1/10, right? Everyone agrees, yes? Okay. But I need it to be not 1/10, because is 0.11111 bigger or smaller than 1/10?
Smaller. Bigger.
You can't just say both. Would you rather have 10 cents, 0.10, or 11 cents, 0.11? 11 is bigger, yes?
11 cents would be bigger.
So this is bigger than this, yes?
Yeah.
So if I add this, 0.1, and that was 1/10, I must need a fraction, yes? So it has to be 1, but it can't be over 10, and it has to be an integer. What's the next integer? We just talked about integers. 0, 1, 2, 3, 4. What's the integer around 10? There's 2. There's 1 on each side of it. What are they? No. 0, 11, and 9. If I have 1/9 or 1/11, which is bigger than 1/10? This is tricky. 1/9 is bigger, right? So this equals 1/9. Prove it. 1 divided by 9. 1. Okay? So what would 2/9 be? If 1/9 is 0.11111, what do you think 2/9 is? 0.22222. Oh, and look what the next question is. Oh, see how I did that? 2/9. Now we get to trouble. What do you think is D? 54/99. Good guess, because there's something repeating. There's 2 there and there's 99, right? But let's have a look. What happens on our calculator if we do 54 divided by 99? 54. Is that right? Only the 4 repeats, yeah? Huh? Yeah, because the screen fills up. 5454, 5.5, it's going to round up. Right? 0.54 is rounding up, yes? Right? So that's why that's happening. So here we are. This didn't work. But we know we have something repeating, don't we? Whenever we see a repeating number, we know we got to put a 9 on the bottom. Do we have anything other repeating? There's no other numbers repeating, right? So, what number represents nothing? 0. Now up top, and this is the time I'm going to teach you a little trick. Normally I teach you why something works. I'm going to teach you a trick. This is 54 minus 5. 49 over 90. Because the part that doesn't repeat is being removed from the whole thing. Everybody understand? So what would be 0.29 repeating? What would that be as a fraction? What would be on the bottom? 90. And what would be up top? $29 minus 2, which would be 27 over 90. Everybody cool? All right. Very little bit of work tonight. Page 20. All you got to do is look at these and decide which of these fits. That's it. That's all you got to do. Everybody cool? Today I had to talk longer than normal because we had to go over all that exponent stuff that we would have done yesterday, right? So that's why I'm only giving you the